Welcome back, my star students. We back at it, part 4, 0 to 100. That 100 is necessary to pass. You need that.
All right, guys. Hey, we're on part 4. All right. Let's keep rolling. All right, guys. Hey, so constellations are made up of more than one star. The data set below shows the number of stars that make up 5 different constellations. All right, so we have 23, 30, 37, 23, and 48. All right, it says what is the mean number of stars per constellation. I'm gonna show you 2 different ways to do this. The first way, guys, is by hand. All right, 23 plus 30 plus 37 plus 23 plus 48, and we're going to add all that up and divide by 5. All right. And this gives you 161 divided by 5, which is 32.2. All right. This right here, guys, is the mean. All right. The other way I wanted to show you was with the calculator. All right. If you go to your calculator and you press stat and let's see here, edit. And then we're going to clear our list 2 out. We don't need it at this time. All right, but if I go over here to list 1 and I enter those numbers in, 23, 30, 37, 23, and 48. All right, if we enter those into our calculator, then press stat again, and we go to one variance statistic, option 1 right here, this first one. All right, and then calculate, guys. It'll give us our mean. Our mean is our X bar, 32.2. All right, so the calculator will solve that for us, 32.2. Okay. Now, for this next data set, guys, it says find the standard deviation of these numbers right here. So again, we're going to use our calculator for that. All right, we're going to enter those values back into our list 1. So stat and edit. And in list 1, we're going to enter our new values, which are 10, 12, 14, 15, 18, 20, and 23. Like that. All right. And then we're going to go stat again. Same thing, one variance statistic. All right. Enter on that. And we're going to find our sigma. Okay, our sigma right here. This is our sigma, 4.24. All right, 4.24 is going to be our standard deviation. Okay. Sigma is your standard deviation. So standard deviation of 4.24. Okay. Now, it says make a box and whisker plot from the data from problem number 27. All right, so our box and whisker plot, guys, let me go back to our calculator and show you this. All our data can be pulled from our calculator. If we use our down arrow right here, our 5 number summaries right here, our minimum, our first quartile, our median, our third quartile, and our max. All right, this is the same numbers we just plugged in. All right, so for our box and whisker plot, if I go here and I had a number line, all right, I'm not even gonna make a number line, guys. I'm just gonna sketch a box and whisker plot for you. But yeah, let's make a number line. If we make a number line like so. All right, and we go 10, 12, 14, 16, 18, 20, 22, 24, 26, right? Now our minimum, or if you go back to your calculator, your minimum is 10, all right? So here's our minimum, 10. All right, that's our minimum. Our max is 23. So right here between 22, there's our max. Now, first quartile is 12, and 20 is our third quartile. So 12 and 20. And then 15 is our median. So here we go. Here's our box and whisker plot right there. And again, all this came from the calculator, guys. Our 5-number summary. All right. Again, the minimum is 10. The max was 23. The first quartile was 12. The third quartile was 20. And the median is 15, guys. 15. All right, we got all that from my calculator, okay? All right, now let's go ahead and look at number 29, guys. For our expected value problem here, guys, you can't see the direction, so look on your sheet. It says the table shows the probability distribution for the number of people who contract a disease in a scientific study. Find the expected number of people who contract the disease. All right, so here we go. Let's go ahead and do this. To find the expected value, all right, we're going to take the number of people and we're going to multiply by their probability. All right, so 2 times 0.20. All right, we're going to do 3 times 0.32. And we're going to do 4 times 0.288. And we're going to do 5 times 0.1536. And finally, we're going to do 6 times 0.0384. All right, like so. And when we do that, sorry about that. When we do that, we're going to get, make sure you do that in your calculator, guys. And when you do that, you get the expected value equals 0.35104. All right, so there's our expected value. All right. Number 30 says the probability distribution for the number of defects in the shipment of alarm clocks based on past data is given below. Find the expected number of defects in the shipment of alarm clocks. Guys, you do this problem right here exactly like you did the previous one. You're going to do 0 times 0.82 plus 1 times 0.11 plus 2 times 0.04 plus 3 times 0.02 plus 4 times 0.01. And when you do that, you're going to get an expected value of 0.29. All right, so there we go. All right, guys, so now, man, right here, 31, it says in a survey of 80 students, 25 said they plan on attending a pep rally. The school has 550 students. Which of these numbers describe the population? All right, so guys, look, there's 80 students. They surveyed 80 students. 25 of the 80 said they plan on attending the pep rally. The school has 550 students. Guys, this is the population. All right, this is the population. All right, 550 students. All right, that's the population. Okay, that's what we're looking for. For 32. Right here it says Kareem asked 30 people in his physics class whether they enjoy eating lunch in the cafeteria. 18 said yes. All right, so we can make a proportion out of that, guys. We can say 18 people out of 30 said yes. Okay? Now, because again, he asked 30 people. 18 of that 30 said they do enjoy eating in the cafeteria. Now, Kareem knows that there's 860 students in the high school. All right, we're going to estimate the total number of students in Kareem's school who enjoy eating lunch in the cafeteria. So, guys, we're going to set up. All right, we got a probability here. All right, that we're going to set up. We know that this ratio 18 to 30 is a sample size, okay, and we need to find the overall population. Or excuse me, the overall the members of student body that enjoy eating in the cafeteria. So we set up this proportion right here. Now you're gonna cross multiply. All right. So what you're gonna do is you're gonna do 30 times x. There's 30x, and 18 times 860 is 15,480. All right. And now solving this, we divide by 30 on both sides. and we get X equals 516. So based off this sample size, we conclude that 516 students enjoy eating lunch in the cafeteria, okay? Now, as we look at number 33 here, in a survey of 40 employees at a company, 18 said they were unhappy with their pay. So again, we can set up a ratio right there. We can say 18 out of 40. Now, 18 out of 40 is the sample. All right. There are 180 employees. All right. Now we're going to predict the number of employees who are unhappy with their pay. So we're going to say X out of the total 180. Again, we set up this proportion and we're going to cross multiply. All right. So when we do that, we get 18 times 180. That's 3,240. And we get 40 times X. It's 40X. Now we're going to divide by 40 on both sides. Alright, and when we divide by 40 on both sides, we get X equals 81. Alright, 81. Now, 34. In the same spirit, man, we're going to continue this thing. In a survey of 20 sophomores at a high school, 8 students said they would prefer a class trip to an amusement park rather than a museum. So again, that's 8 out of 20 sophomores. All right. Now we know that there's 150 sophomores. The sophomore class is 150 students, right? So we're going to use that to predict the numbers of sophomores who would prefer a class trip to an amusement park. So again, cross multiply. So 20 times X is 20X. All right, and 8 times 150 is going to be 1,200. All right. So now we need to divide by 20 on both sides like this. And X equals 60. All right, guys. X is 60. All right, number 35 here. This is going to be our last problem for our Unit 10 video. 35 asks, a community association surveys its members about who they'd like to have as the next chairman, Hickory or Washington. In the survey, 36% Hickory, 64% Washington. The survey margin of error is 6%. Determine whether the survey clearly projects a winner. Explain your response. All right, so let me do this so we have a little space to talk. All right, first of all, we need to figure out what the actual range of votes are for each member. All right, so Hickory, I'm going to do Hickory in red. Hickory had 36% of the votes, right? Well, his actual margin here, guys, because the margin of error is plus or minus 6, all right, if I subtract 6 from 36, I get 30, all right? And if I add 6 to 36, I get 42%, all right? So Hickory actually received 30 to 42% of the votes, okay? Washington received 64% of the votes, all right? So if I take his 64% and find the actual range of his votes based off the margin of error, all right, I get, again, 64 minus 6 is plus or minus 6. So 64 minus 6 is going to be 58%. All right. And 64 plus 6 is going to be 60%. Okay. So his Hickory votes are actually somewhere between 30 to 42%. Washington votes are somewhere between 58 to 60%. Now it says determine whether the survey clearly projects the winner. And the answer is yes. All right. The answer is yes, because there isn't any overlap, guys. There isn't any overlap. All right, here's what I mean. See 30 to 42, there are no numbers. All right, from 30 to 42, there are no numbers that fall in this range from 58 to 60. And there are no numbers from 58 to 60 that fall in the range of 30 to 42. All right. So, guys, listen, man, this concludes the video. And I hope this helps, man. You understand Unit 10. All right, tune back in to my next video, which goes over Unit 11. All right.